Hi, my name is Kelsey McCormick, and I'm going to give you a presentation on a publication that we put together in 2019, which is an overview of the current 3D modeling activities taking place at a variety of geologic survey organizations. So the driver for us putting together this publication was really due to the growing recognition of the societal value that geoscience data was having, whether it was with geological mapping, visualization, and modeling to support a variety of applications, also in support of science-based decision making, for sustainable resource development and public safety. So the objective of this publication was to highlight the recent successes, accomplishments, as well as the challenges that were experienced by a number of these geologic survey organizations as they were developing and deploying their 3D modeling programs to support a variety of stakeholders. This wasn't the first synopsis to be produced. The first one actually was done in 2011 and had contributions from 9 different jurisdictions. The 2019 update actually provides contributions from over 22 jurisdictions. And we use a slightly different format to produce this synopsis volume. So part 1 really gives a bit of an overview, the background, the purpose, what's the current state of 3D modeling, globally. Another really interesting chapter in here that I'd recommend having a look at was the cost-benefit analysis of 3D models. We'll talk a little bit about it more in the presentation, but it's definitely a chapter worth reading, especially for jurisdictions that are looking to provide some additional justification to fund programs in 3D geology. Part 2 was the contributions from the 22 jurisdictions, and the format approach that we took in this case was to provide a series of sections that we asked each jurisdiction to fill out. So that way it allowed us to do some really interesting comparisons across the jurisdictions for a variety of topics. And we'll talk a little bit more about those in the presentation as well. For part 3, it's really just a kind of a conclusion and summary, but there's some interesting chapters in there that highlight the value of and different mechanisms that surveys are using to communicate their 3D geology to stakeholders, as well as some really great overviews on some of the global 3D initiatives taking place, and really also provides some of the new kind of innovations and interesting applications that some geologic surveys are taking to really kind of push 3D geology to the next level. So the size of the jurisdictions that are encompassed in those 22 groups that submitted information vary quite significantly and quite substantially, from just over 31,000 square kilometers to close to 10 million square kilometers. So it's quite a range in the sizes that some of these geologic survey organizations are responsible for mapping and modeling. Now, interestingly enough, 6 out of the 17 organizations reported that they will, by 2019, or already have 3D models that fully cover their jurisdiction. So that's really impressive. And it kind of goes without saying that every other jurisdiction that contributed, that's really their intent, is to enhance the coverage they have. I think everyone's working towards that 100% completion, or they're trying to infill and include additional geologic units and resolution to their models that they currently have in place. Now, this was a really interesting kind of comparison in that most of the geologic survey organizations have been doing 3D geology and building 3D models for less than 10 years. However, interestingly enough, 12% have been doing it for more than 20 years. So there's some groups out there with a wealth of knowledge, and this is a really great opportunity for us to connect and bring that 3D geology community together and learn from each other, because there's quite a number that have been in this and doing this work for quite some time. So lots of good lessons learned. Of the geologic surveys, 10 out of the 16 have actually formed dedicated modeling teams. So that really shows a great advancement and recognition for the value that this is bringing to a variety of surveys. Now, the size of those, of the number of modelers in with each of these surveys varies quite significantly. If you see from the bar graph below, the majority have less than 5 modelers or people that are part of the team, the modeling team. But three organizations have more than 50 working on producing 3D geology products. So that's substantial. As for the modeling approaches that are being taken by the variety of surveys, this was a really interesting component to look at because as you can see, almost 50% of the surveys are using 5 or more software packages to support the construction and dissemination of their models. So you can see there's no one program to use. It's really about mixing and matching and finding the programs that are going to best suit the data, the information you have, as well as the geologic complexity that you're trying to work within. So again, great opportunity to reach out and connect with modeling groups and talk to them about what programs they're using and why they're using those various programs to support their modeling activities. It was also really interesting to see that the vast majority of surveys are trending towards multi-scalar models. So they're not building models at one scale for their entire jurisdictions, but rather acknowledging the fact that a variety of scales might be required based on either the data density or sometimes the applications or uses of those models. They really are going to, the scale of the model is going to vary based on location. So as for the primary users of these models in this 3D geology, it was great to see that 100% of those agencies are supporting or are seeing their models being picked up and leveraged by government agencies. 84% reported they're building models in support of environmental agencies, 74% for academia, 53% for public use, 47% for industry, and 32% for regulators. So you can see, there's a range, and that, there's obviously some opportunities to enhance the uptake in some sectors in terms of the use of some of the models. So as for the application and drivers, here you can see the first one here is just geothermal. And so each one of the little individuals represents a geologic survey. So you can kind of get an idea of the relative proportion of surveys that are building their models to support specific applications. So for geothermal, that's quite a few. Minerals, we can see quite a number as well. For the energy sector, groundwater by far had the most. Almost everybody's doing it for groundwater applications. Urban infrastructure, great to see that's on the increase in the rise. Building materials, and like public health and safety and hazard mitigation was another one that was at quite high in terms of the number of surveys that are leveraging 3D models for those applications. And then waste disposal, not too far behind. So the benefit cost of the 3D geology, it's significant. This was outstanding to see. So the return on 3D modeling activities, it can be, on the low end was 4-to-1, which is not so bad. On the high end, over 100-to-1. So you're not going to lose out by dedicating funds towards 3D geology. It results in better informed decisions, opportunity to enhance communication with stakeholders. There's a risk reduction, mitigation that can be, and those costs can the cost of building the model to the potential savings are astronomical in that space, as well as for resource identification and to prevent sterilization or contamination of those resources. So for when it comes to building these models, we can talk about all the benefits and all the directions people are going, but it was also really interesting to see what are organizations challenged by. And I won't go through all of them, but the top three right here, you can see are data management, which to no end, there's lots of data that's being ingested to support these models. So managing that data was one of the top challenges. The technology, hardware, software, it's a growing area. So we're seeing lots of proliferation of software availability and hardware. With that transition from the physical computer to now cloud computing, that's going to be a game changer, and already has been a game changer in this space. So I'm sure we'll start to see that challenge be overcome in the next little while. And this was an interesting one, was access to modelers or subject matter experts. That seemed to be a common challenge as well. So education and enhancing people's understanding, familiarity of 3D geology, and as well as the implications and the understanding of how these software programs are being used. We don't want to see them be used as black boxes. We want to make sure we have a good understanding of how that data and that information is being translated into the 3D visualizations that are being produced and ultimately being leveraged to support decision making. We need to make sure we've got highly qualified personnel in those positions. And we can hear from a number of surveys that can often be a challenge. So for lessons learned, some of the key ones you can hear quite the high percentage was the importance of model access. We are really striving to find ways to share those 3D geology models and information with our stakeholders. That's also improving, but it has been quite the challenge. Flexible modeling approaches, that's definitely something that, I think from a number of surveys have said that's some lesson they've needed to learn. You can't be too stringent and have, say, a one process fits all. We need to take a flexible approach and have multiple approaches or mechanisms for constructing these models based on, varying scenarios, whether it's data, complexity, application. The value of data management is a key component, key lesson to learn when building and disseminating models. The value of communication is also, I don't even yet think we've capped and fully understood the value that these models can have to our stakeholders. And as well, the need for workflows. This is a great budding area and allows us to refresh the models as new information and data comes in, and also help mitigate user error, because there's a lot of steps in building these models. So if we can generate some workflows that can help us streamline the process of building the model and integrating new information into the model, and enhance the updates, but also mitigate the potential for error in those multiple steps. Those are also some areas that I think have been some game changers over the last while. So as for next steps, most surveys are trying to improve their model access. So that was one of the lessons they learned, and you can see people are really taking strides for online access and web access to their information and data, getting their models into places that they can be interactive and users can import their information and data from and extract data. So those kind of portal sites, if you will, are quite what many surveys are striving for right now. We're also seeing a growing need to develop 3D programs in geologic survey organizations. So either people have a few modelers in place and are trying to build the program, or they have quite a few and the program's kind of building and growing, enhancing on its own. But it was great to see that most surveys are trying to grow and build upon the modeling programs they already have or have planned for the near future, as well as integrated modeling. I think this is a great step. Many surveys are leveraging the geologic information they have to act as a geospatial framework with which they can integrate other information and data. So it really becomes an integrated resource model to understand the complex nature of multiple resources within that geospatial environment. So as for the predictions for the future, 3D geology is going to be crucial in our understanding and our ability to understand and characterize the complex and integrated nature of the environment and the resources. So what we're going to be seeing more of is organizations working to integrate that surface information they have with the subsurface models. And that they can create fully integrated models that allow people to easily toggle between what's at surface and what's in the subsurface, as well as integrating a variety of resources and data types within the subsurface. So you can really have a more holistic understanding of what's happening within that consistent and validated geospace or geospatial environment. This is a crucial component to supporting holistic evidence-based decision making, and that's a great way to see that geologic and geoscience information leveraged in the future. The other component I think we really heard loud and clear was that communication bit. 3D is going to really allow us to leverage the phenomenal geoscience information that is housed within many of these geologic surveys and get it out to the hands of our stakeholders in ways we've never imagined before. And many of those are going to be some really interesting, innovative, interactive technologies, such as virtual reality, even augmented reality. 3D prints, amazing way, very tactile. And, in this case, you can see some images of some young children learning about the subsurface environment through these 3D models that they can take apart and rebuild. But we've also seen that leveraged in, with decision makers and individuals with a variety of backgrounds to make sure everybody's on the same page and understanding the implications and what's in the subsurface. So the models can be used for a variety of applications in that way as well. Some really great stuff happening in UK, Germany. I don't want to miss any here, but the groups that have been taking their subsurface geology and leveraging like popular platforms like Minecraft as ways to engage and get people interested in learning about geology in all new ways. We're even seeing it kind of pop up in science centers, and as ways for people to understand what's beneath their feet and engage with that. And especially for subject matter experts, being able to, put that information and data in that 3D context, it gets everybody to see the same picture. And if you say that, a picture is worth 1,000 words, then these models, these 3D models that allow us to rotate and understand and fully visualize what's happening in the subsurface, those are novels that we're able to communicate in a matter of seconds. So the key messages are that data is a valuable resource. These models are data hungry. They thrive on information and data, and we can improve them, quite significantly by ensuring we're putting high quality data and information to support those models. It's not just data. We want to make sure it's high quality data and information. So managing that information and data, ensuring that there's appropriate access and supply of that is key to support sustainable development and diversification. The benefits of building the 3D geologic models far outweigh the costs. That we're hearing loud and clear, and there's some phenomenal examples that are provided in the chapter on the book, as well as I think they're coming out constantly now as we're seeing some really great case studies, being able to capitalize on and capture some of the costs as well as the benefits. So some really great studies coming out in the last little while. And you know what? This is the perfect time to start. Here often, people would say, well, what do I need to kind of get started? And a 3D program, and it's not much. You don't need much. You need some data, some information. You need, someone to take the initiative to get going. And you just got to get started. And there's so many great groups around the globe that are willing to share what they've learned and the processes they've taken and do their best to try to help people, skip over some of the hurdles that they had to experience as they were learning to get their models and their modeling programs up off the ground. This is the perfect time to start. There's quite a proliferation of models and modeling activities taking place. So don't ever hesitate to reach out and learn from your colleagues. And yeah, just keep on modeling. And so where can you get a copy of the synopsis? Well, you can download from the Alberta Geologic Survey website, and I've provided the link on the slide. We also do have a not many, but we do have a couple physical copies. And so if you are interested in one, we could try to get you a copy. Just reach out and send me an email. But by far the easiest way to get one quickly and efficiently is going to be to get one from the website. They're there free of charge, and if you have any trouble accessing it, please let me know. So with that, thank you very much for your time and attention. And if you have any questions, please let me know, and I'd be happy to answer whatever questions come my way. So thanks again, and I look forward to hearing from you.
So thank you, Kelsey. And thank you, everyone participating today. Thank you for submitting your questions and discussion through the chat. And I, again, am Harvey Tharlifson, Minnesota Geological Survey, your moderator today. And we just heard from Kelsey McCormick of the Alberta Geological Survey. And so, Kelsey, you mentioned the very positive cost benefit. You've mentioned that it's possible to get into this activity without a major investment, but at the same time, people are noticing that 3D programs do have large budgets in some cases. So Kelsey, can you please expand on how to build the rationale to attract the significant funding that can be required?
That's a great question. And realistically, I mean, getting kind of started, there's a lot of at this time there's a lot of great software packages out there, and some of them can be quite costly, but there are quite a number of them that are rather inexpensive or offer significant discounted rates to non-for-profit organizations in particular. So it's great to reach out to people, and you can find out why they've chosen certain software packages to start constructing their models. And a lot of it has to do with either the type of data you're trying to integrate or build a model from, or potentially could have the complexity of the geology you're trying to model. So with the software, and with as long as you've got some information and data, you can get started. I think a key component though too is having somebody that's knowledgeable and can work to integrate that information and data, construct that model. But once you get those models up and running and people start interacting and using them and see how easy they are to then get everybody on board with the subsurface geology, you start to integrate some information and people see how they can be used to support decision making. That's often, I would say for myself, when I first kind of got going in this, as soon as you built one, then people wanted, well, can you do one for over here? And well, now what if we integrate this information and data? And have you guys thought about including this data? And before long, we had more data being thrown our way that some of our decision makers and executives wanted to see put into the models. And it didn't take long to then gain support and have additional funding start to be put towards either to support data with data management, which was a key component, as well as for acquiring additional software to be able to do additional or use the models for additional applications. So it's I don't think there's one perfect solution. I think it's maybe going to be a bit easier now. There's some really great case studies, as I had mentioned, and Keith had mentioned as well. That can also be used, or feel free to use that information to help kind of gain support for transitioning into, constructing 3D models. So yeah, that would be, I would say, kind of the summary kind of on that is it's really just to kind of get started and get stakeholders engaged, and before long you'll see quite the uptake, no doubt.
Very good, thank you, Kelsey. The next question from the chat asks whether geophysical and physical properties are integrated into these public sector models in a manner similar to the way that the energy sector operates.
So that's a great question as well. There's quite a variation, and a lot of it depends on sometimes the confidentiality issues with certain data. So various jurisdictions have different confidentiality issues with their, whether it could be borehole data or some of their geophysical data. So it can vary quite significantly from one jurisdiction to another, the type of data and information that's integrated into the models that are made publicly available. So I would say it can be one or the other or a combination of both. And it's probably more typical to see a combination of both. But that being said, the proportion of, say, your geologic data versus some of the geophysical information and data, that would vary from jurisdiction to jurisdictions in terms of the relative composition. But both are in there, and I would highly recommend leveraging both data types if you're able to. But certainly for, like, say, if it was an internal use model, it's definitely possible to be able to do that. It's just when you start to cross that threshold to then making some of those models publicly accessible, you definitely need to be considering confidentiality issues that may exist with the data.
Very good. So thank you again, Kelsey, for that very helpful overview of the incredibly rich volume that you drew our attention to. So thanks again.